This is Mr. Holsey with 8 Squared Sufficiently Understood Science, and today we're going to be looking at weather fronts. Now, before we begin discussing fronts, we need to understand what an air mass is. An air mass is a large body of air that develops over a particular region of the Earth's surface. Typically, these are divided into either warm air masses or cold air masses, because one's going to be a little warmer or cooler than the other. So there are 4 types of major air masses that fall under this warm or cold banner. So we have continental tropical, which is represented by a lowercase c and an uppercase t, continental and tropical. These usually are formed over warm land. So when you see that term continental, think continent, which means it's formed over land. And so this is going to be warm and dry. Now let's think about this for a second. Why is this going to be warm and dry? Okay, it's dry, warm because where it's formed is the land is warm because of its proximity to the equator. But it's going to be a dry air mass if it is formed over areas like a continent, which doesn't have any large bodies of water to supply it with moisture. Then we have a continental polar, okay, lowercase c, capital P, and this is going to be formed over cold land. And so since it's formed over land, it's going to be dry. And because it's formed over land that is considered cold, probably in the northern latitudes, it will be cold. Now we have the other type, marine tropical and marine polar. So, maritime is what I meant to say. Maritime tropical or maritime polar. Reason I was saying marine is that was what I want you to think of. Marine, as in the ocean, large bodies of water. So a maritime tropical, lowercase m, capital T, is going to be, and we're talking about tropical, so we're talking around the equator, is going to be formed over warm water. And because it's formed over water, it's going to have lots of moisture. And obviously, since it's warm water, it's going to be warm. So the weather will be warm and wet. Then we have maritime polar, lowercase m, capital P. So we're talking polar. So we're talking about the poles, which are cold. And so since it's formed over cold water, it will be wet and cold. And so we can kind of see different areas where we would find these. So on this map, you have the maritime polar, the continental polar, the continental tropical, and the maritime tropical. And so if we look on this map, we see we have a maritime tropical right here, which is formed around the east coast of the United States in the Atlantic and in the Gulf of Mexico. And so this weather will be warm because of its proximity to the equator, but it's also going to be wet because it's bringing in moisture. On the other side, we have the continental tropical. And so since we have a continental, meaning it was formed over land, we have tropical, meaning it's warm. The weather here is going to be warm and dry. And over here, we have a maritime polar. You can't really see the M up there, but it's up there, trust me. We have maritime, which means it's formed over water, and polar, which means the poles. And so our weather here is going to be cold and wet. And finally, over here, we have continental polar. And so we have continental, which means it's going to be dry. And then polar, which means it's going to be cold. And that tells us a lot about how different fronts are going to form along these air masses. So when we're talking about fronts, we're talking about the boundaries of these air masses. Okay? The weather that's formed on the boundaries and following it as they move along land masses and in the ocean, as they move along the globe. And so fronts are kind of like two different armies, okay? And they're always pushing and pulling against one another and fighting for position. So let's take a look at some of these weather patterns. So one thing to remember is that the type of ocean surface current that passes by has a direct effect on the climate and weather of the land nearby. And so these are color coded for you so you can kind of get an idea. So the blue California current is going to be a cold water current. The red current up here, the Alaskan current, is warm, and the Gulf Stream is warm. So warm surface currents bring warmer, moister air to the surrounding areas because as water is warmed up, it begins to evaporate. And so we have this warm water that creates warm, moist air to the area surrounding it. But cool surface currents bring cooler, drier air to the surrounding areas. And so this is why as we discussed in a previous video, areas like Great Britain and France, especially Great Britain, even though they're really in latitudes that are way up here, where they should be really cold all the time, they have a warm water current by them. And so that has a direct effect on the type of climate and weather that areas like Great Britain experience throughout the year. So cities in these areas enjoy the same stable climate throughout the year. The ocean helps keep everything stable and unchanging. And that's really important on our planet. Without the role of the convection currents in the oceans, climate would not be that great. Right here, obviously, near Houston, it's fairly warm, it's fairly moist all the time because we have the warm waters of the Gulf to help stabilize our climate. So these areas where the streams are affecting the type of climate are called maritime climates because they're being directly affected by the ocean. Remember, maritime meaning marine or ocean. And they rarely experience any big dramatic changes throughout time. So Miami, New Orleans, Houston, Seattle, San Francisco, San Diego, they all have similar climates, or not similar climates to one another, but stable climates to one another. So these are examples. And so what do we know about these climates? Well, Houston is hot. New Orleans is hot. Miami is hot. It's pretty much year round. Seattle is almost all year round, kind of dreary. It does have a nice summer, but it gets lots of moist rain. In fact, that's one of the only places in the United States that's nearby a actual rainforest. One of the rainforests in the United States. And so areas like San Francisco, though, even though it's in California and we think of sunny California, San Francisco is actually fairly temperate. It can be quite chilly. And so they are directly affected by the ocean currents that go near them. Now, the issue with this is the farther you get away from the coast, the more dramatic the weather changes throughout the year. So if you think about these places along the coast, they tend to stay about the same, but areas more inland, they have more significant weather changes throughout the year, more dramatic shifts from winter to summer. And these are called continental climates. Summers can be very hot and winters very cold. Rainfall can vary tremendously throughout the year. And so they are more continental climates, the areas not on the coast, are more likely to have big shifts. So areas like Pittsburgh, Memphis, Minneapolis, Denver, Oklahoma City, Dallas are examples. And during the summer, and like for example, let's take Oklahoma City, because I actually used to live by there. I lived in Norman, Oklahoma for a couple of years. And in Oklahoma City, during the summers, it'd be 100 degrees, dry, and just, really kind of crazy hot. But during the winters, it'd be such a huge shift. I remember where we would have these blizzards in Oklahoma. It's 100 during the summer. Most of the summer, it's incredibly hot. But when it came to winter, it was just extremely cold and very, very strong winds. And so big shifts because they didn't have that stabilizing climate due to the maritime currents. Now, that's climate. That's the overall, like, throughout the entire year, how things are. But as we know, that's not always the case. Sometimes things are going to change from day to day. And so we need to start looking at weather. Now, on any weather forecast, you're going to see areas of low pressure, usually signified by an L. So low pressure areas form when warmer air begins to rise high up into the atmosphere. Now let's think about that. Remember convection currents. Warm air rises. But why would it be low pressure? It's because of density. The warmer the air, the less dense it becomes. The colder the air, the more dense it becomes. So kind of think of it like a hot air balloon. So this low pressure areas form when warmer air rises up into the atmosphere. And as the warm air rises, it begins to swirl counterclockwise and pulls moist, humid air up with it. So as these low pressure systems suck air up and bring warmer and weather where that warm wet weather is going to go wherever they go. Now they're usually associated, these warm fronts or low pressure systems are usually associated with bad weather, and this has some really warm and humid air, and as it rises higher and higher, it starts to cool and forms clouds and precipitation. And so those warm fronts, that's what the low pressure systems are called, warm fronts. Even though you might think that they are, you hear on the news, oh, a warm front's coming in. You expect that it's going to be sunny and you can go out and do things. But in reality, it's going to be cloudy and rainy the whole time. Now, you're also going to see areas of high pressure. These are going to be signified by an H. So these high pressure areas are going to be cold fronts. These areas form when cooler, denser air begins to sink back down to Earth like a leaf blower, blowing down. And as the cool air sinks, it swirls clockwise and blasts cool, dry air back down to the ground. You're probably thinking, oh, great, this is going to be freezing cold temperatures. But in reality, it's going to kind of even out Because look at that, cool, dry air. That means we do not have a lot of precipitation. So the sky is going to be clear and sunny, and that warmth of the sun is going to kind of even it out. And so having a high pressure system come in actually kind of like takes the clouds away and gives us these really pretty days. So, like I said, these high pressure areas usually bring dry and sunny weather with them. And these are actually your nicer days is when a high pressure system is coming in. And low pressure is going to bring a lot of moisture and some pretty severe weather, but so can high pressure systems. And we'll get to that in just a minute. Now, they're usually associated with great weather. This is really dry, cool air, and no moisture means no clouds or rain, just beautiful sunny days. So if a high pressure system is in your area, more than likely you have a beautiful sunny day going on. Now, pressure systems usually deal with the amount of moisture in the air, though. Big dramatic changes in air temperature come from moving fronts. So a front is the boundary or dividing line between two different types of air. So warm fronts are in front of low pressure systems. Okay, so that's a low pressure system. In fact, I'm not going to use yellow. I'm going to use the correct color, red. And so that kind of helps you, and that did not work. Let me change that. There we go. All right. Okay, so that's a low pressure system because it's warm. All right, so kind of think more along the lines of color here rather than, that H means hot or anything like that. Okay, so warm fronts are characterized usually by red, and they generally move from south to the north and bring warmer, humid air with them. They're characterized by these little round shapes on the lines. So if you ever end up with a black and white version of this, you're looking for those round shapes. So the direction of these half circles are telling you which direction the front is moving. So if we are here and we're currently experiencing a really nice sunny day outside, and we have this low pressure or warm front coming in, we can expect that as this low front moves over, we're going to end up getting moisture and rain. It'll be cloud cover for most of the time until that low pressure system or warm front moves through. Remember, fronts are just the beginning of an air system. So as the front moves through, it drags the associated weather with it into the area. Now, cold fronts, which are characterized by, let me see if this works better. Yeah, that works a lot better. An H, okay, because they are high pressure, they are more dense, whereas low fronts are less dense. They generally move from north to south and bring with them cooler, drier air. And just like with a warm front, the direction the triangles are pointing tells you which direction the front is moving. And so let's say we are over here and we are just having a really bad time right now. So you have lots of moisture in the air. I can't draw lightning very well. Okay, got lots of moisture. Maybe we had a low pressure system over us and we had lots of moisture. It's been raining for a few days. As this cold front moves in, it's going to get rid of that moisture because it's cool and dry. Now, if there is enough humidity in the air, which means evaporated water, you'll usually experience some rain and storms as the fronts move through the area. You can even with a cold front, which is usually characterized by dry weather, as it moves that warmer weather out, that wetter weather out, it is going to build up the clouds. So colder temperatures cause evaporated water in the air to condense into liquid water, which means we're going to have a massive growth of storms. So this can cause rainstorms as the cold front moves in, causing this warm water to be shot, or warm air to be shot up very high as the cold front moves under it. Okay, cold front's going to move under it and out. And so this warm air is going to get pushed up very rapidly. And as it's pushed up very rapidly, we're going to see some severe storms. Pretty strong thunderstorms can form along cold fronts, but behind it, we're going to have that nice not wanting to do its thing. Sunny weather. The worst sun ever. Okay. Now, the storms that form along these cold fronts can spawn tornadoes and things like that. So it is pretty strong weather. So let's take a look at some special weather situations. So we have rain shadows. These are areas of dry land that receive little rainfall on one side of a mountain. And so I'm going to highlight this in green. So I'm actually going to use the highlighter here so we can still see some of the stuff here. Okay. So this is a range of mountains. Okay. Right there. And so these mountains are rather tall. So on one side of the mountain, okay, we're going to have lots of storms and rainfall. Because while the side of the mountains closest to the ocean get drenched in rain, because these moist, humid air coming off the ocean can't make it over the tall mountains. So it's going to consistently pour on one side and stay dry on the other. So that's why you can have really nice weather in more humid weather in places like California, Oregon, Washington, and then just on the other side you have Arizona and Wyoming and Utah that have very dry weather. Even though those fronts should move through, because of the mountains, they fall into a rain shadow, which keeps them from having a lot of precipitation. So Phoenix and Seattle are really good examples, because Seattle gets near constant rain, like near constant. It rains there almost every day. But Phoenix, Arizona gets very little rain because it falls on the other side of this mountain range. Now let's look at another special weather situation. Hurricanes. These are massively huge low pressure systems. So let's think about that. So if it's a low pressure system, I need to switch back to red for that. So it's a low pressure system. It is characterized by having a warm front, and so it is warm and wet. Well, that's exactly what a hurricane is. It's fueled by warmth and water. Okay? It needs heat and it needs water. And so these massive storms are going to develop throughout the summer and fall in the warm tropical waters. And the specific heat of the water allows it to heat up slowly and gain a lot of energy. As it comes in, it's going to gain strength as it goes across the ocean, and with the warmer waters. And then when it comes onto land, where it's cut off from its energy source, it begins to weaken. So as it comes to land, it's going to dump a ton of rain, because and often is going to flood the area. You know, so let's take a look at a specific how weather fronts can and air masses can really make hurricanes really bad. So this is a weather map of what happened during Hurricane Harvey, which is really bad. Um, so remember, fronts are like two fighting forces. They want to take the same space, so they're pushing back and forth. And so up here, and I'm going to use green up here. So up here we have a high pressure system, okay, or a cold front, and it's moving in a clockwise direction. Over here we have a low pressure system, and it's moving in a counterclockwise direction. They're basically pushing against each other, and they're kind of stuck. And so Harvey, this low pressure system, wants to move up and over. That makes sense. And that's typically what would happen. However, this high pressure system is bringing in a heat wave to California, okay? And then the storm there is another high pressure system right here. And so this is what spelled so much disaster, because Harvey slowed down significantly as it came in. Most hurricanes are moving really fast, but Harvey slowed down extremely because it basically got boxed in by the high pressure and low pressure trough to the north. It couldn't move. And where it got stuck is what made it so dangerous. Because as we can see, I'm going to try to highlight this in purple. So here's the coast, and there's the storm. Okay, so this thing is moving counterclockwise. All right, because we're in the northern hemisphere, and so it's moving counterclockwise. And so the storm was stuck over warm water. It was stuck over warm water. It was also partly on land. So it was almost half and half. And so the storm continued to pull moisture from the Gulf of Mexico. And so it just kept dumping more and more moisture on the land instead of moving on over, a lot more distance and dumping that moisture and dying out as it went on the land. And so it actually got stuck. And so rain just kept coming and coming and coming. So let's review our types of fronts. We have a cold front. There are 4 types of fronts we need to know. Okay, we have a cold front, which is a fast-moving cold air mass that overtakes a warm air mass. You can see right here, high pressure system. So the cold fronts on this one are highlighted right here. We got another big cold front right there. And you notice the long chains of storms here as the fronts interact. Then you have a warm front, which is a warm air mass, which overtakes a slowly moving cold air mass. Which is in red with the half circles. Then we have stationary fronts. And this is where cold and warm air masses meet, but neither can move the other. And so they are stationary, they get stuck. We have occluded, and so those are characterized by alternating the warm and cold front symbols in opposite directions. And then you have occluded fronts. So where this one's kind of weird, and I'll show you a diagram of this in a second. So where a warm air mass is caught between 2 cooler air masses, and they're usually characterized as this kind of hybrid, You got triangles and half circles and triangles and half circles. Kind of hybrid. Red and blue makes purple. So a cold front is going to come in and push under a warm front. So let's take a look at the characteristics. So a cold front is marked on a map with a blue line and blue triangles pointing towards the warm air. It's associated with cumulus and cumulonimbus clouds ahead of the front in the warm air. And so along this front, behind the cold front, once again, you have really pretty weather. Okay? But in front of it, it's going to produce powerful showers and thunderstorms because it's pushing that warm air up rapidly. Then you have a warm front where warm air rises above and down. This air is going to be very moist. And so you would think warm would mean that's pretty and nice, but it's going to cause more evaporation. And so basically it's going to be like cloudy skies. It may not rain all the time, but it will drizzle and have really cloudy skies behind it. And so this is going to be marked on a map by a red line with red semicircles pointed toward the cool air, or in the direction the warm air is retreating to, because we got to think convection currents, because it's all based off that. And it's generally associated with stratus type clouds. These are those little wispy ones and stuff like that, way up high. Overcast skies, fog, and general rain or snow. So warm fronts bring snow. Go figure. Then we have stationary fronts, basically where two air masses just can't get past one another. And so they're pushing against one another. And so they can't move. These are going to be marked by alternating blue lines and blue triangles pointing in the direction of the warmer air, and red lines and red semicircles pointing in the direction of the cooler air, because they're pushing against one another. That's why they're pointing to where the. So if I were to ask you a question, I said, okay, what side is the warm air? What side is the cold air? This triangle here is the cold front, and it's trying to overtake the warm front. So the warm air will be on this side. And then on the opposite side here, we have the red semicircles. That's the direction the warm front wants to go. And so on this side, we have the cold air. And so water vapor in the air condenses into rain, snow, fog, or clouds. If it remains over an area, it may bring days of clouds and precipitation, because nothing's moving and it's just pushing up more moisture into the atmosphere. Then we get kind of one of the strangest ones. It's called an occluded front. This is where you have, because warm air rises, you have a cold front that is, so you have two cold fronts here. You have two cold air masses. Essentially, you had a slow moving cold front, more cool air, that was being overtaken by warm air behind it. But then you had a fast moving cold air that dived under the warm air and pushed it up. So you end up with these two cool air masses that are pushing up a warm air mass. And so these are going to be marked by a purple line with an alternating purple triangles and purple semicircles, all pointing in the direction of the front movement, because they're not pushing against one another exactly. They're all moving in the same direction. So the weather may turn cloudy, and rain or snow may fall, because that moisture in that, if you remember, you had the cold air, and then you had another cold air, and up here you had the warm air. Okay. And so we had cold, cool. No, don't need to do that. and warm. And so the clouds are going to get pushed way up high. And as they go higher up in the atmosphere, that moisture is going to cool. And so you might end up with rain, but depending on the time of the year, you may end up with lots of snow falling. And just kind of oversimplifying things and make sure we got this 100%. High pressure versus low pressure. High pressure is heavy air. It's going to be sinking and you're going to have happy weather. Okay? Happy. High pressure, happy weather. I know. Low pressure is light air. It's less dense. It's rising. And you're going to have lousy weather. And once again, that's because you got the high pressure, the more dense air falling. Low pressure, you have lots of moisture rising. And that's going to do it for our tutorial on fronts. Remember to like, share, and subscribe to see when we post new tutorials. And as always, this has been Mr. Holsey with H Squared Sufficiently Understood Science. We'll see you for the next tutorial.